So this enhancement set by this T-SQL is an extra, is an added value that would be imposed on the SQL, and it would be an added value to developers and let's say project administrators, system administrators, uh, where they can actually see an easy life upcoming. Let's see the short index that we're going to pass through upon this unit. Mainly, we see actually the main and the pillar functionality that the TSQL presents to us in order to yes, to represent the view where we see the TSQL in action. First understand and first concept that we have to define whenever we talk about the TSQL integration in a project is that we are going to deal with the secure code, because we are actually the secure context and security context, so we have to present the secure code side. I give you the example. We saw the unit number one and chapter number one when we defined the SSDT and the APIs. We defined the at the end we defined the views, we defined the chain script, we defined the action of refactoring, object refactoring, and debugging the views. When you talk about the view, to generate a view, for example, and the view holds a long statement, a long query, select fields from object one, object two, object three, where condition, order by, group by. It's a long query. Good. So we generate a view. The view to do what? It would be actually use define name to call it later in order not to rewrite the code again, to avoid duplication. Then it is a cover that would secure at a level, at a level, limit security, the query from being actually injected or something like so. So the query would not be utilized, but the view would be utilized. And the view would lead us to reach the query. Thus, we are at the end of the day just making a select. It's simply extraction. It's simply display of data from the backend. So the creation of a view, the utilization of a view, this is a way of securing the code. We are interrogating it, we are exploring it in a sense that the code cannot be exposed. The select query is not viewed by the end user at the end of the day. He is only seeing the view. The program is calling the view. The code is calling the view. The view is being debugged. And the program is linked to the view and executing the content of the view. The select is the last thing to be discussed. Thus, it is at a level, when I say at a level, because there are also drawbacks, and there are actually limitations, there are points where we see the efficiency of the view. Yet, at least, we are covering, at the first view, we are covering the select and the query inside the view. We are not exposing it. So, that's so. The perspective behind the enhancements set by the TSQL, they are for a view of securing the codes and securing the content, securing the project fully, in totality. Whenever we are dealing with a database or a back-end data store. Securing the code is not an abstract definition to say, but at least there are techniques we are going to apply, techniques we are going to deploy. We're going to go after specific methodologies, security architectures. Thus, they are not something obscure. They are not something actually, let's say, asymptotic. They are not actually clear for us. No, they are at the beginning. We are dealing with recognized technologies and recognized techniques, security techniques. When we say, well, for example, I take the obscurity context here. I declared it earlier. So we are going to deal with hiding the queries from being exposed. This is one security act. This is one security act to hide the query or the code or the solution It is one isolation level. It is one security technique. It is one action, one architecture and security. So clearly, we are securing the code. Whatever digital security deploy within this chapter that enhance the trust versus DB data flow. Mainly, this is the component that we are going to secure. So when we are going to secure the transaction, what is a transaction? It's a select, or it's an insert, or an update, or something similar. It's a SQL query or group of queries. So it is an interrogation, either coming from the API to the, it's a request from the API to the backend, or a response from the backend to the API. It's a data flow. It's a data flow to be secured. Any questions? Any appraisals, please? One one very important actually sector is the terminology. Actually, you have to be very familiar with the terminology in context of security, since you are web design and information security major students. Here we are seeing group of terminologies, but they are 100% related to the database security context, and mainly they are related to the SQL Server environment. Starting with the first one, the T-SQL. This is not new. We saw it since the first unit. T-SQL is the transact SQL, transact structured query language. Are you still seeing the presentation, please? Is it still visible to you? Please just declare. Are you with me? Okay. The CLR, this is a new term. Actually, we're going to explore step by step, but I'm going to give you the first definition. CLR, common language runtime. Common language runtime. It's a sort of a procedure. It's a sort of procedure to be executed, created, executed, and deployed inside the SQL server itself from the backend. Means we're going to generate a procedure and execute it at the backend itself on the SQL server in our context itself. The CLI, it's a procedure to be executed only from the SQL server, and it has to be at the runtime. Means it will be generated and stored inside the SQL Server environment. Later on at runtime, when needed, the program will execute it, will deploy it. So it will be kept inside the SQL Server and utilized at runtime only. It's a procedure for now, because we're going to define the stored procedure right after. For now, CLR is a procedure, and you know what is procedure. It's just a function that does not have a return, no data type return, no return at all, but created at the SQL Server environment itself and executed at runtime. Utilized and called and executed at runtime only. Trigger, the context of the trigger, actually, if you pass through the course related to the ASP.NET content, web design, web application, or web database and dynamic web design, those courses, they are defined as the event handler that you have to utilize at every time you need to fire an action. That's the trigger is the same context, but the trigger has actually a specific predefined methods that we're going to pass through. The trigger, at the end of the day, it is a sort of a firing event that would launch an automatic action from within the project environment. Mainly, we talk about the SQL Server environment. The trigger, it's an event handler. It's a firer of an event. At the end of the day, the trigger. Come on, cancel. What's the problem? At the end of the day, the trigger. Nothing. At the end of the day, the trigger is a firer of an event. Firer of an event. It does fire an event. It launches an event. It executes an event. It starts an event. For example, I give you an example. At midnight, I need the database or the project to execute the change script. At midnight, I need the project to execute the change script. And we define in unit number one what is change script. If there are updates in between two, if there are differences in between two snapshots, so the change script will be generated and then after deployed at a later time. So the execution of the change script on the live database, I need it to be done at midnight. I will not keep controlling the time. The computer will do it by himself. Once the midnight comes, so the trigger would be firing the event of executing the change script. So what is a trigger? Trigger is an event firer. It is an event starter, we may say that executes events automatically from within the project. It's a sort of, let's say, procedure sometimes. Yeah, predefined. Predefined. From the SQL Server, we are having predefined units that they are acting as triggers. Stored procedure or SP. Stored procedure, or we may also use the word we may use the word SP. Good. Stored procedure. We defined earlier the CLI. We said that it is a procedure stored from within the SQL Server environment and it would be executed at runtime only. It is a procedure. It does group processes and stops there. The stored procedure is the same thing. It is a procedure and it does an activity to be executed at runtime also. Yes, and it has to be stored at the front end API, the SSDT, the SSMS, the Visual Studio, or the APIs we may refer to interconnect to the SQL server. There we may store the stored procedure. So the CSP, the stored procedure, it is a CLR, yet not stored from within the SQL Server environment. It is stored at the API level. What is API? The API, as per the unit 1, the SSDT as an example, SSMS, Visual Studio, or any other application that gives us the chance to get connected to the SQL Server environment. There, we may store a procedure named stored procedure. What is it? It's a procedure. It does a task, and it stops there. It does not have any return. Why we generate it? We generate it to execute codes later on. Stored procedure. We generate it to execute codes later on in the program in order not to rewrite and duplicate the code again and again. We just call the procedure. That's it. We have a block of code to be recalled again and again whenever needed. Database objects. Database objects. Remember that inside the database we don't have only tables. No, tables, they are the pillar and the first object to be created. Yes, but they are not unique. Inside the database, we might have different objects, and those objects, they are the actors inside the database. Entities, yes. Stored procedures, yes. Views, yes. Triggers, yes. T-SQL, CLRs, yes. All the components that they construct the work of the database, the project, they are said to be objects, or they are included objects. Remember, the first security architecture we set and we defined that the unit number one related to the database security is the physical security. Objects, they are the number 4 in the physical security. They are the number 4 component from the physical architecture that we set in order to secure the environment, starting from the server until the objects. Objects are the deepest in the architecture. Memory overflow. We define this in the digital security course. Memory overflow. Still, it is one of the concerns of the data manipulation. Since it is actually dealing with the memory and the data, the storage, still the same context is valid. What is it? As per the first definition, it is trespassing the limit of the, let's say, the data part in the RAM given for a project or for an application or for a running process. and thus it caused the memory to be stacked. It overflows the limit to stack the memory, and then after it causes a computer to stop from running the full project, and even the computer might be blocked and might be stacked. Due to what? Due to Because only simply the program has passed his limit of memory space without permission. Thus, it is named memory overflow. The memory utilized by the specific program for execution and for running, it is not enough for a reason. If it has been trespassed without declaring to the operating system or to the CPU unit, it would cause the computer to stuck. The full project will stuck, and even the computer might stuck also, get stuck also. Memory overflow. Stuck. If you finish the cybersecurity course, you have to remember that from that perspective only, that the memory, the volatile memory, sorry, the volatile memory is not to be utilized by one unique program. No, it is to be utilized by all the runner programs in computer, whether it is 1 GB or 6 GB or 16 GBs. The full RAM would be segregated into parts. For example, if we're utilizing the uh, Microsoft operating system, we talk, for example, about Microsoft Word. We talk about the Excel. We talk about the any other programs that they are going to be run on computer. Slides like this one, they are going to be running at the same time. Yes, they might be on the same RAM. This is good. How it happens? Because the computer, the operating system, it would segregate for each program a specific space. 500 MB for this program, 1 GB for this program, 100 MB for this program, and so on. It will subdivide the RAM into spaces, and each program it will give him the operating system would allocate a specific space for each program. Let's say for this presentation, for example, the computer is allocating half GB in RAM to run this, which is actually a very big space. Whatever. This half GB space to this application, it would be segregated into 6 parts. 6 parts. Six, let's say, blocks. The RAM would be segregated into 6 blocks. Those 6 blocks, the part responsible for data named stack, because the program is not only data. The data, for example, the text we see, the background we see, the colors and so on. This is the data we see. The data area is named stack inside the RAM. Inside the RAM, the data area, or the data what we see, we as humans, the space dedicated to store this data is named stack inside the RAM. The other parts each has its role. We don't care for now because we saw that in cybersecurity. Thus, a stack is one of the concerns to secure, like we do to secure against the memory overflow. We have to secure this stack from being, let's say, compromised by other external programs. If we reserve, let's say, as per the example here, for example, for this example, if we reserve 512 MBs for these slides, no other program can utilize those 500 MBs except this program here, the slides we talk here. If the operating system reserves this space, so this space has to be reserved for the program. No other programs are allowed to use this space. Thus, the stack is a question of security. It has to be secured here. It has to be secured. It does not give us security, but it has to be secured. Any questions, please? I need to hear your voice. Are you here?
Just here.
Okay. Still in the terminology only, we as we define the stored procedure, there is another component that we are going to face also through this unit, the extended stored procedures, the extended stored procedure in singular. It is another stored procedure view, yet the parts building up the stored procedure, they are segregated into different APIs. One computer number one, second server number one, third computer number three, one another one in the geolocation number one, and so on. Extended stored procedures is at the end of the day it's one stored procedure, yet holding different parts, let's say a multitude of parts, and each is in a location. They're not on the same computer. They are not on the same API. Let's say they are not all together, or they might be actually interrelating components inside the computer. If we talk about, for example, linking assemblies or external memories, operating system memories to the project. So we utilize an extended stored procedure. What does this mean? An extended stored procedure simply is an SP, stored procedure. It is a stored procedure, very simple. Yet, it has functionalities to be integrated from external environment. As per example, libraries from the operating system. Operating system and the operating system is something completely different from database. So if we link any function from the operating system, we have to utilize a stored procedure, and thus we are given the name extended stored procedure. Why extended? Because it utilizes external resources. Simple. The last, the SQL CLR stored procedure. We define the CLR and we define the stored procedure. We define the CLR earlier and we define the stored procedures. CLR stored procedure, CLR SP, is the same CLR and it's the same stored procedure, yet it is a combination of both. One part is stored if you are declaring or creating a CLR stored procedure. So it is a one procedure but holds a part stored inside the SQL Server environment and the second part stored at the API itself. Altogether they are functional. Once the trigger launches this procedure, both of the parts would act, the CLR part and the stored procedure part, since they are only one unique stored procedure at the end of the day. Is it clear? Is this clear, please?
Yes, Mr.
Okay, I pass. The SQL is presented to us new features that we are going to utilize, and this is because of the benefit we see through the T-SQL enhancement. Starting actually with the data types, mainly briefly, starting with the new data types. New data types means the SQL server is defining to us new data types that we might utilize to implement our solutions or our projects. New data type. What is data type? Like we see, for example, int A, int B. The int, what is it? It's an integer. It's just a data type. The same way here, there are new data types specific to the SQL server. To reach those data types, to reach those data types, to create them and utilize them later on, there are scenarios behind. We'll come to this. Creating actually a stored procedure leads us to understand that the SQL server can enhance specific and customizable processes to be implemented. Yes, absolutely. And thus we define the thing user defined functions, UDFs. User defined functions, those are customized processes to be done and implemented due to the understand and the request of the end user, the developer. User-defined. User-defined functions. The table valued parameter TVP is one of the solutions that the SQL Server enhances, and this is actually a sort of an architecture that helps us to define maybe actually a user-defined function. We may define a stored procedure. We may define actually a process to do. But what is it as an object? Uh, is a sort of a graphical table to be controlled within the program. When you create a new table and we generate it and we manipulate, we insert, we update, we delete, and so on, it's the same way here. Table valid parameter. We are going to define a new type, and this new type would be declared as a table. Later on in the program would be utilized whenever needed. There are actually there are as per here we came to understand that the table the TVP is a data type and specific to the SQL Server and would be utilized in the program later on. And why we refer to create a table like this? Actually, because tables, they are to be specific for a specific task. We may create an association, if you understand what is the association very well. We means actually it's a concatenation of two um, primary keys from two different or interrelated. They have relation two entities inside the database. In order not to regenerate them again and again, you just create a data type, and you are going to utilize this one to define all the objects from the same with the same architecture. It means if they are having the same architecture, we're going to utilize the TVP, the predefined TVP, to define them. Generation of the user-defined functions can cause a breach, a data issue, which is actually a context of an overloading. This overloading means a user in a long program may fail or fall into an error which is generating of new functions with the same name as earlier declared. So overloaded. We are utilizing the same names, some same nominations for two different methods, which is an issue here. An issue. There is an overloading. There is a scenario that pushes us to respect the way how we program and we solve the issue. Sorry, whatever it means solve the issue here, I mean the project task. But if we fall into naming two functions, two user-defined functions with the same name, so we are same name and same parameters, we are under the context of overloading. And the overloading, as the word is overloaded, it's a context that we have to solve. There is a rule how to implement this. We may have it as a solution, but it depends. From first view, overloading is a security issue because the overloading can impose if it is permitted inside a program, can impose the injection capability, means can be utilized and explored by externals and let's say external parties to inject malicious script into the program, the overloaded. Can you repeat what is the security issue that the overloading impose? Can you repeat what the overloading represents as security vulnerability or issue, please? What does the overloading represent? Can you repeat? I just said now. Are you with me or not? Benefits, side effect, and let's say positive effects of the TVPs is that we are able, like the views we declared earlier, that we can utilize it again and again. It is a type that we are going to define. It's user-defined type, can be utilized again and again and again without redefinition again. Just recall. Shardily maintained. What does it mean here? Shardily maintained means that if we declared at the beginning of the program, we need to update the declaration part only block if any modifications happen. Later on, every and each single call to the type would be automatically updated because it is not compiled. It is an interpreted context here. Whenever we call, it would be called again from the original, let's say from the server side. Uh, thus, it is to be centrally maintained effectively here in the sense of the declared type. Once updated, all the instances of this type utilized later on, they are to be seen the updates automatically. Give the example. We are going to create a user-defined type, user-defined type as an alias to call later on inside the program whenever needed. The first alias is to int, not null. Every additional single declaration of a variable inside the program as int, not null, we are declaring it as ID. We are generating new type named here الاسم الاي هذا نقدر نغير الى اي شيء. Oman, we can change it to Oman for example. It's user defined. It's user defined. Let it be ID. If we use the word ID inside the program, means we are declaring the thing as int, not null. Every call to this ID later on is an int, not null. The same way here. This is the second statement. We are declaring a new type given the name location, and this location here would cover the varchar 100. Later on inside the program, whenever we call this location, means we are defining a varchar 100 size new object. The creation of types is not a restriction to SQL Server. It's not a restriction to SQL Server. No, we can see the types inside the Oracle also be implemented with the Oracle itself and other professional database management systems. They also enhance such feature, which is the TVP. And what is the TVP now? As a final understanding, the TVP is a type that the user defines. It's a type that the user defines, and this type has a specific structure that also the user defines. We need the int null, int not null to be utilized inside the program so many times. So we may define a new type that we utilize inside the program again and again without rewriting the code again. So this is one of the benefits of the TVP, the reusability. Still in the same context, let's see here the first definition of TVP. We are creating a type given the name customer user DT, user data type. This word here, customer UDT, is user defined. Customer UDT, user defined. There is no rule. Create type. This word here from you as a table. Also, we are specifying what is the type. It's not like here. Now we are modifying a little bit. We are defining a table as a data type, user type. And this table has the following structure, the following architecture. 3 columns, 3 fields. ID as an int, customer name as an varchar, and postal code as an varchar. Again, we are defining a new data type, new type, user defined type, which is having the architecture of a table that has 3 columns, 3 fields. The first one, ID as int, customer name as an varchar, postal code as an varchar also. 3 of them, they are going to be utilized inside the program once the customer UDT is called only. Any questions, please?
No, Mister.
Okay, if you hear your name, please just type yes. I'm going to take the attendance. I'm going to take the attendance now.